This example comes out of section 4.4, Applied Max-Min problem. So this is a cost question, somewhat realistic, I suppose. Cable needs to be buried to go from a power plant to a cabin. The cabin is located across a 400-meter river, 1,000 meters downstream from the power plant. It costs $50 a meter to lay cable underwater and $30 a meter to lay cable underground. What's the cheapest way to lay the cable? So let's draw ourselves a picture. We have ourselves a river. We've got a power plant on one side of the river, so let's call that P. The cabin is across the river and downstream, so let's call this C. The size of this river is 400 meters, pretty huge. And downstream here, we have this is 1,000 meters. We'd have options ranging from going straight across the river with the cable and then all the way downstream, which would be the longest route to take, but you'd be doing the least underwater cable. Or you could take directly from P to C, which would be the shortest distance, but it would be the most cable going underwater. So we don't know, or it could be anything in between. Truth is, it is something in between. So let's, draw something in between those. So we'll lay the cable underwater to a certain point, and then we'll go on land the rest of the way. So let's call that point, x meters upstream, which leaves me with this length that we're going underground to be 1,000 minus x. This distance that we're traveling underwater, I need to call something, so maybe I'll call it y for the moment. So the total, what we're trying to minimize is our cost. So we better come up with a cost equation. That's our objective. So our objective is to minimize the cost. Cost is going to equal $50 times y plus $30 times the distance going on land, which is actually 1,000 minus x. That's great, but we have two variables in there, so that leads us to our constraint. Our constraint consists of the fact that this is a right angle triangle that relates x and y. I can say, well, x squared plus 400 squared equals y squared. So y just equals the square root of that, of x squared plus, and maybe let's make it 400 squared, 16,000,000. So we can substitute that into our cost equation. Say cost equals 50 times that, the square root of x squared plus 160,000, plus, and let's multiply 30 times 1,000, so 30,000 minus 30 times x. Good news and bad news, slightly more complicated derivative than we've been taking, but it is at least all in terms of x. So we find dc by dx, and we have to take the derivative, use the chain rule, and then we're going to have to let that derivative equal 0 and solve for x. So let me try to cut the length of this video down by doing some steps on pause here. So first of all, use the chain rule to get yourself that first piece of the derivative. Then go take that a step further and simplify a little bit. Half times 2, so I've got 50x over the square root of x squared plus 160,000, and then minus 30. I want that to equal 0 because I want to max or min, in this case a minimum, the cheapest way. So if I solve that, I've got 50x over the square root of x squared plus 160,000 needs to equal 30. I can do a little cross multiply, but at some point I have to square both sides, and that's what leads me to this 2,500 x squared over x squared plus 160,000 equals 900. So take it a step further, multiply that denominator to the right, and then solve for the x if possible. I've got 1,600 x squared equals 144 million. The numbers are a little bit gross here, but x squared equals 144 million divided by that. So you end up with x squared equals 90,000, so x equals plus or minus 300. The negative answer, again, in this context doesn't really make sense. What we need to do is aim to a point that's 300 meters downstream. If you look up at the diagram, if you make x 300 meters, you're going to run the cable across and then run it than only 700 meters onshore. So we could find the cost, but they've said what's the cheapest way. So you could describe that, given that diagram, X needs to be 300 meters, and so you could also find what Y was if they asked you to, or you could find the cost by putting X equals 300 back into your original cost equation and say how much does this actually cost you.